Thank you for joining and registering for this webinar on energy storage. I'm Rishabh Jain and lead the market intelligence team at the Center for Energy Finance at the Council on Energy, Environment and Water. This webinar is part of the ongoing webinar series where we plan to discuss the challenges, opportunities, and the emerging trends in the clean energy sector in India and beyond. The Council is one of South Asia's leading not-for-profit policy research institutions. It uses data, integrated analysis, and strategic outreach to explain and change the use, reuse, and misuse of resources. The Center for Energy Finance acts as a non-partisan market observer and driver and monitors, develops, tests, and deploys financial solutions to advance the energy transition. It aims to help deepen markets, increase transparency, and attract capital in clean energy sectors in the emerging economies. It achieves this by comprehensively tracking, interpreting, and responding to developments in the energy markets while also bridging gaps between governments, industry, and financials. I'm joined by my colleague Akansha Tyagi from the renewables team and of course Rupam from Fluence. Before we start, few points of hygiene today. We would request the participants to stay on mute. In case you have any questions, please share them on the chat box. We'll spend the next 30 to 40 minutes asking questions to Rupam and then open the floor for discussions around 3:15 p.m. The webinar is being recorded and we'll share the recording on YouTube for easy access, and I hope you find the webinar useful. I now hand over to Akansha to set the context and also introduce Rupam. Thank you.
Good afternoon, everyone. Welcome to this webinar. Traditionally, the energy storage systems have been used in a decentralized manner to store energy. They have ensured the availability of power at the consumption sites or used as a starter in conventional vehicles. However, with the grid becoming more dynamic and unpredictable, energy storage systems have found novel applications in many parts of the grid. Broadly, usage of energy storage systems can be classified in three broad areas: to integrate more renewable energy in the grid and ensuring grid stability and security, providing 24/7 power, and in the transition to electric vehicles. However, the understanding of the energy storage systems and its impact remains limited. With the drastic reduction in upfront costs and new technological developments, new avenues of applications are now commercially viable. Currently, India has around 6 gigawatt of pumped hydro storage and a few pilot projects on grid-connected battery storage. Tata Power, AES, and Fluence had set up India's first 10 megawatt hour project, and recently, in a welcome development, two developers, Greenco and Renew Power, won a bid to develop a hybrid project with solar and wind supported with the energy storage system. Going forward, we expect to see more projects at generation, transmission, and distribution and consumption sites. An increase in prosumers and transition to a smart grid will ensure the development of new business models to deploy the technology. As a part of this webinar, we plan to discuss the role of energy storage systems in transition to electric vehicles, ensuring energy access and grid stability. We will discuss the key regulatory interventions and financial support required to ensure energy storage systems are scaled up in the country. Today, we have with us Mr. Rupam Raja, who is the Market Director for Fluence India and Southeast Asia. In this role, Rupam is responsible for market development activity in the region. He has successfully developed a portfolio of grid-connected battery storage projects in the Philippines, providing frequency support services to the national grid. In India, Rupam is supporting the operations and maintenance of the 10 megawatt 1 bar battery storage project developed by the AES, Mitsubishi, and Tata Power DDL, where Fluence is the technology provider. Prior to Fluence, Rupam worked with an international environmental risk consultancy, and before that, he was developing renewable energy portfolios for a private equity group for a global IPP. Rupam has a master's degree in international business from the Thunderbird University in the United States. Welcome, Rupam, and thank you for joining the webinar today. I would now request you to share your initial comments on this webinar we have planned.
Sure. No, thanks Akansha, and thanks Rishabh for the intro, and thanks for having me over for this webinar. So my name is Rupam Raja. I work for Fluence Energy, and like Dr. Tyagi said, I'm responsible for the market development in India. Just a little bit about Fluence. We are a joint venture of Siemens, which is a power sector major, and AES, which is a US-based IPP. Both of these are big names in the power sector, so that's where our DNA is coming from. And I just want to highlight that battery storage, energy storage, battery-based energy storage is the only thing that Fluence does. I mean, we are not, a chemistry company that makes batteries. We are not an inverter company that makes inverters. We are not a container company that makes containers or an HVAC company that makes HVAC systems. We are a power sector company that brings all of these things together to deliver a power solution. Okay, having said that, globally, we have close to about 1.6 gigawatts of, developed or under development grid-connected megawatt-scale battery storage projects. These projects are spread across 21 countries at this point. And in India, we have, in fact, what is the largest battery storage project in South Asia, which you talked about. The one that's been developed by AES and Mitsubishi, and it is operating at a TPDDL substation in Rohini. We are the technology providers for that project.
Okay. Thank you, Rupam, for the initial comments and the introduction. And before we start, and this is also one of the things that we were talking before the webinar itself, is that other than the cost of energy storage system, do you think in India, the scaling up, the scaling up cost is a major barrier, or awareness about the technology and the application is the major barrier? And how difficult do you find to at least inform people about the potential applications and the use cases for energy storage in the country at this moment?
Right, no, sure. So, I would say, the awareness about the value that battery-based energy storage can add to, the Indian electrical ecosystem, right, the power ecosystem, I think there is fairly good awareness. I think the openness of Indian policymakers, regulators to something new is much more than we have seen even in some of the developed economies, right? Although I would say that awareness is not uniform across the country. I mean, there are states that are more open to it, and then other states that are not. Now, I would say that on that same awareness, front, right, I would say I think more awareness is needed on the pricing side. I think there's a perception of the price of battery storage, which I would say is at least 2 years old, or at least it was embedded about 2 years ago. And we've seen, policy documents, for example, we've looked at some NITI Aayog documents, in fact, where the price points that were put for battery-based energy storage were actually quite a bit higher than where the sector is right now. Right. So I think while there is awareness on the technical capabilities of the system, I think there is, although like I said, it's not uniform across the board. I think people have to understand the way prices of battery storage have changed over the last few years and the way they're projected to change. And in addition to that, the kind of risks that the private sector is willing to take and the kind of, the animal spirits, if you will, that kick in to actually make these things even more, feasible in our system.
Okay, that's very interesting. One of the things that we often, as in the discussion that often comes up, is how do you characterize battery storage? And when I say this, I mean in megawatt or megawatt hours. We often draw parallels with solar and wind projects where we talk about what is the capacity of projects that are installed, gigawatt, megawatt, all of these, and we don't talk about what is the megawatt hour production of these from these solar systems. But the cost for energy storage would depend highly on what the application is. What is it, a power application or energy application, what megawatt and what megawatt hour. And this makes, I guess, the whole situation very complex. To simplify things, what do you think would be a simple approach to ensure that, okay, one, people understand the technology, but don't fixate on the price itself? Like, right. And what should be then the best thumb rule? Should we always talk about 1 megawatt hour, 10 megawatt hour?
Yeah, no, sure. So I think right now, right, I mean, people love to talk about battery storage as an energy application. People just love the idea, it's a very romantic idea of, that I will use the sun during the day, charge the battery, and I will use the battery during the night. I think that's the kind of romantic idea of battery storage. And I think, and like I said, it's a romantic idea, right? I think where we are seeing battery storage add the most value in the power system right now is where battery is used as capacity, right? And I think, having said that, I think at this point, where the prices are and where the technology is and what we are ready for to deploy as commercially viable, I think it makes more sense for us to look at battery storage in capacity terms and not in energy terms. I think there is a future. My job is to look at the market right now and see what can be done right now, but there is a future where you could talk of it in energy terms as well, but it's not now.
Okay. And in terms of the Indian grid itself, what are the key services or at least the key voids do you think the energy storage can probably fit in at this moment?
Right, yeah. So there's a whole list of things that batteries can do. I mean, some of them more important than the others. But if you look at it from across the value chain point of view, right? I mean, batteries can add value at the generation level. Batteries can add value at the transmission level. They can add value at the distribution level. Batteries can add value behind the meter, at a commercial industrial establishment as well, right? So yeah, across the board, I think it adds value. And it's just a question of, finding what that application is in a given instance and go for it.
So as you said, there are like a bunch of applications that storage will offer. What do you think are some low-hanging fruits which battery storage can actually make sense right now instead of waiting for the market to develop further?
Right, yeah. So I think, so if you look at the project we have in Delhi, in Rohini, that is a low-hanging fruit. In terms of what does it do? I mean, exactly. So there's a method in India. It's called deviation settlement mechanism, which is our way of having in the lack of an ancillary market, it's our way of enforcing some grid discipline. And it's a perfect tool for a distribution company to make sure that its draw off the grid matches its schedule, which it rarely does. And everybody's in dire need of something that helps them match their schedule because they're fined for it, they're penalized for it. And battery storage is an excellent tool to be able to match that, that schedule with the draw. And people think of, my peak load is, 1,800 megawatts, and what will a 20 megawatt battery do for me? You will be surprised, right? I mean, there's a band that you're operating in, a distribution company is operating in, and that band is in tens of megawatts. It's not in hundreds of thousands of megawatts, right? And if you add a battery storage component to it, you could very easily double your band, right? And have that much more space to be able to stay within the limits beyond which you will get penalized, right? So I think that's a big role that we see right away, right? I think that's a clear one that's fairly obvious. And the other thing is, you can also do energy arbitrage, right? So you can, there's a lot of abundant energy in India during the day. There's a lot of abundant energy because of must-run, not must-run, but, technical minimum plants, and there's a lot of abundant energy available at night as well, right? So you could use your batteries with that abundant energy and use it at a time when you would be otherwise paying a peak tariff, right? So there's a use, for that as well. Now, the biggest role that batteries can play, right, is because of the amount of renewable energy that we're adding to our grid, right? So what we're doing is, and I think it's fairly well known now, the duck curve, and you call it by different names depending on which part of the world you're in, but we are adding so much solar during the day, and we are backing out our coal power plants because of all that solar, right? In the evening, when your demand rises and you have no solar anymore, you've got to ramp up these coal power plants to meet the rising demand, right? The ability to ramp up at that space does not exist. I mean, I've been very closely involved in this issue for the last 2 years. And I've been told for the last 2 years that we are working with the Germans and we are working with the Americans. We're trying to find a way to basically ramp up our coal power plants. And we knew as a company that this was not feasible. It cannot be done. I think 2 years later, people are beginning to realize that it cannot be done, right? And to make up for that lack of a resource that can ramp up at the pace at which it's required to, and the fact that nothing exists right now, only battery storage can fill that role. I think that's a very important role as well.
In addition to that, say a complementary application can also be when a thermal power plant cannot go beyond the technical minimum, as in below technical minimum,
right.
And it has to, say, generate at 60%. So the excess can also be stored in the battery. And this would also have an impact on the emissions, right? The per unit emissions would reduce because the lower you are functioning.
Right, because you're running it more optimally, that's right, yeah. Like I said, it's a long list, and I don't want to go to the entire list, though they were less important than others, but there's one more that I'd like to add is CapEx deferral. We have these instances called super peaks. They may happen like 5 days a year for maybe 5 hours, and we tend to we build the infrastructure to meet those super peaks, right? You can very easily deploy battery storage for those super peak instances so that you don't have to incur that CapEx. And then 2, 3, 4 years down the road, you can look at what does your demand look like? Can you still use the battery you have to meet those super peak instances? Can you double the amount of battery that you have right now? Or should you go in and make a capital expenditure, right, to meet that? Because now it's not a super peak anymore. It's happening more frequently than a super peak, right? So I think the battery gives you those options. I think that's the fourth low-hanging fruit for battery storage.
Okay. In the initial discussions, Rupam, you had mentioned that you've been, and Fluence has been here for 2 years now, and the last 2 years has also been very turbulent for the energy storage sector in the country. We saw a lot of tenders, a lot of cancellations also. As a company, then what is the strategy that you're then probably designing? Do you continue to depend on government projects, or is there still possibility of participation into private projects where companies may then want to set up large-scale projects itself? Or would you, for at least a short period of time, focus only on SECI NTPC projects?
Yeah, so Fluence, we are a technology company. I mean, we are not a developer, or an investor, right? So our approach is going to be to team up with, whoever wants to develop a project, whether it's a public company or a private company, right? We are in 21 markets. If you had asked this question, 2 years ago, the number would be maybe 15. It's not a very old industry, so to speak, right? I think where we are in India is maybe things that could have happened a little bit faster, but I think we are happy with where we are right now.
Okay.
We are happy with the fact that unequivocally policymakers, regulators understand the value of battery storage and what it can do for the grid. I think that is something that's clearly understood. 2 years ago, if you look at the NEP electricity plan, there was no mention of storage. If you look at the report that came out in July from the CEA, there's a clear identification of a gigawatt number of how much storage you're going to need in the 2029-2030 timeframe. There's a number in the 2022 timeframe, right? So I think all of that is development. About us being in India for the last 2 years, in fact, Fluence in the energy storage business through our parents, has been in the industry for over 12 years now. We started our first project development in 2007 in Chile at a coal power plant, and that project was commissioned in 2009. So for 11 years, that project has been running. It's been providing, battery storage, energy services to the grid for the last 11 years. And it was at a coal power plant. And quite similar to the situation we have over here. We have a lot of coal capacity that is being underutilized. And we believe that, with battery storage and with all that's happening on the RE front in India, there is room to better utilize those coal assets. I think battery can play a big role in that.
Interesting. You briefly mentioned about this project in Chile, but the projects that you've set up in other countries, in 20 plus countries, what have your learnings been from these countries, and which of those learnings do you think can translate directly to India itself?
Yeah. So, I think the rest, there's a lot of learnings in India as well. Maybe not in the storage space, but in analogous to storage in the power sector, right? I mean, We believe that if you have goals, if you have goals for energy storage, just like we've had goals for solar and wind, it really helps to grow the sector. I think that's something that has been done successfully in California. It's been done successfully in New York State. India has done it successfully with solar and wind. There's no reason why India cannot do it successfully with storage as well. And there's a clear realization now that with all the RE that we have coming online, we are going to need storage. And there's a need to couple RE targets with storage targets. Otherwise, we could be in a situation that we don't want to be in from a grid stability point of view. I think that's one thing. I think the second thing is clear. We don't have battery storage, battery manufacturing capacity in India. And putting tariffs and putting it under a high tax rate is not going to help us either on the RE development front or on the storage development front, or in the end, stabilizing our grid and making it greener front, right? I think we got to take a pause and make sure that some of these new industries are allowed to grow in a global environment, where we can source equipment from where it's most efficiently available, and not try to, get too greedy and try to tax it, through an import duty or GST or any of that. I think we got to go a little bit easy on these sectors, on this sector for the next few years, to allow it to grow. And I think that's the second learning. I think that's an important part.
Okay, that's interesting, because despite growth, I mean, now we are seeing, at least in the solar sector, there are new tariffs that are being suggested, if not implemented, and they have definite and negative impact on the sector also at this moment. I hope at least on the tariffs or any additional duty will not be implemented on battery storage systems. But one of the things that you also mentioned was the goals, having goals at least for the sector going forward. And this, I come back to my earlier question on how do we set up these goals? As in, do we understand the application better? Will this be a power, energy arbitrage, peak shaving, RE integration, whatnot? And these would probably depend on tender to tender and the requirement of various discounts. But say, for example, the recent tender that we saw, where it was a hybrid, solar plus wind plus energy storage, and the developers were open to choose whatever technology they want. Do you think tenders like these are good going forward, or should we adopt a different model to set up new storage projects in the country?
I think the model is it's worked, right? I mean, it was oversubscribed. It was 1,200 megawatts. It was subscribed for 1,620, and it's they've awarded, right? It's been awarded, right? So if it's an oversubscribed tender and it gets awarded, that's success, right? So I think it's what they've done works. To accelerate it, if there were national level targets, you will see more. SECI is taking the lead on this, right? SECI is taking us down a path where we have a cleaner future, right? That's the path that SECI, they're leading, and the other stakeholders, both Renew and Greenco and SECI. I would say, we are at a moment in history where we will see a different trajectory. We'll see this is a turn in the clean energy transition, right? And I think all the three companies are part of that, right? Now, they would have more conviction in their steps. They'll have more conviction in their actions if there was some support at the economy-wide, with the target as economy-wide, right? You will see more conviction, and you will see us moving faster on that path. So, and I think that's where those targets would help.
Okay, that's helpful. And one question again on the regulatory front is that at this moment, the way the regulatory framework works is that organizations like PGCIL or CEEW-STU are not allowed to sell electricity, if I may say. I mean, of course, they set up and maintain this transmission infrastructure, but there's a clear case of application of storage in transmission and distribution infrastructure itself. I'm not sure if you have had discussions with PGCIL and others, but what are the changes in the regulatory mechanism that you think will encourage scaling up of energy storage in the country?
See, See, I mean, I really, I think the talk of, regulatory impediments is overblown.
Okay.
I mean, there's a project in Delhi's network, 10 megawatts connected to the grid, that obviously had to have some regulatory, if not an approval, at least a regulatory agreement for them to go and do that. It's grid connected, right? So what is the regulator looking for? Regulator is looking for precedents. Regulator is looking for data. And regulator is looking to make sure they're protecting the interests of the consumers, right? And for which they have to see data, right? I believe there are ways right now for a DISCOM in West Bengal to develop a battery storage project, for a DISCOM in Maharashtra to develop a battery storage project, for a Transco in Gujarat to develop a battery storage project. I think there is enough room given by our regulatory structure for them to envision these projects, put them up for regulatory approval, and that thereby create more data to make more of these projects happen. I think that's what's needed right now.
Rupam, I've just put on the images of your project in Delhi. If you want to briefly explain any of these, that would be helpful. Otherwise, there are...
Yeah, sure. Yeah, so actually, if you go to the first one, can the viewers can see this?
Yeah.
Okay. So if you look at the first one, right, I'll talk about the very first project, which is the project we have in Delhi. So that's in fact a 10 megawatt 1 hour project. And actually it's the one before, the one with the, that one, yeah. So this is 10 megawatt 1 hour. What you're looking at is a civil structure, so it's inside a building. Typically our projects are inside containers. This was inside a building. So we had to, so this has got a foundation, so there's earthworks and a foundation, and then the build wall, and you put a roof on top of that. And then inside this you have racks on which you have the storage system, right? So what you have is a core, and in fact, you have 4 such cores, each of them giving you 2.5 megawatts. And what you're seeing outside on the left of the screen are basically those are the transformers that is then stepping up the voltage, and then it goes back to the switchgear, the 11 kV switchgear. So that's the Delhi project. What you're looking at here is a project in Australia. This is a 30 megawatt 1 hour project, and in fact, you talked about, Rishabh, you talked about that a transmission company cannot make money out of energy storage, and that's true. So this is in fact owned by the Australian transmission company, and they have similar rules. They are not allowed to make money out of energy sales either, and they've in fact leased this asset to a local distribution company that then makes money out of the battery storage.
Okay. Yeah. So development of new business models, either as a service you just provide, either for grid balancing or just as a service. I think that is something can be developed in India, and we may say things like these. And of course, the regulations are also changing in the EV space also. We saw last year when the Ministry of Power came up with a regulation that charging your EV is not selling of electricity; it's more of a service. So maybe something clarification on that front will also come up, which will at least help set up more energy storage projects in the country.
So I had a question about technology front. So as you said, like in our previous discussion before the webinar, we were discussing how Fluence examines different kinds of technologies and then selects based on certain parameters. Right. Would you like to explore about that? Like focus more into those?
Yeah, sure. So, for us, I guess one key part of the technology is batteries, right? So Fluence is not, I think of a battery company as a chemistry company, right? Whereas what we're talking about here is a power sector solution, right? So we take inputs, from those chemistry companies, and that's a key part of, the solution that we develop, right? So batteries. So it is very important that when we select a battery, it is technically viable. It does everything we want it to do for our customers. That's one major criteria. The second major criteria is we want to make sure that that company is going to be in business as a battery company, and if there is a problem with their technology, with their warranty, for example, 10, 20 years down the road, we can call them as a company would still be there to come and service what they sold to us 20 years earlier, right? I think that's a very important consideration. And then the last part is, where is the price of their battery going, right? And usually that has to do with how much capacity have they deployed, how many kilowatt hours of batteries are they producing, and how many kilowatt hours of batteries do they plan to produce in the future, because the more of that they do, the more the price of batteries will fall, right? For us to be able to package those batteries in a solution which can then add value for our customers, we want to make sure that it is priced right. So all of those, so that indicator, where the price would be down the road is a very important criteria for us, right? Now, so I think that's like the three major things that we look at before we select a battery technology vendor. And from a technical qualification point of view, we have two labs. We have a lab in Germany and we have a lab in the US. And we have batteries from battery manufacturers around the world. I don't know exactly who has their batteries with us right now, but we are testing batteries to qualify them in our architecture. And it takes, I would say on an average, anywhere from 12 to 18 months before I can say that the battery is going to meet my technical criteria, it's going to meet my safety criteria, it's going to meet my financial, longevity criteria, whether they're going to be viable 10 years, 20 years down the road, and whether it meets my criteria of where the price of the battery should be so that I can meet the needs of my customers.
Right. So then, contrary to the current trend that lithium-ion batteries are dominating the market, you see that there is a future for, let's say, redox batteries or solid-state batteries. If the manufacturers of these batteries kind of provide you the assurance that they have a substantial capacity, there is a substantial business in the coming, let's say, 10, 15, 25 years. You see that also?
Absolutely. Absolutely. If someone comes to me and says, Fluence, here's a compressed air solution, and it's the best energy storage solution that we have in the market right now. Will I evaluate that to see if I can give a power solution to my customers with compressed air? If it compares to battery storage and maybe it's better, obviously we will evaluate that, right? So, but we leave that to the people who are in the business of making batteries or such kind of technical solutions. And if they bring them to us and we qualify them, and if it meets our criteria, then we will use it. Yeah.
Okay, that's helpful. Expanding on this discussion, of course, there are these characteristics that you, or at least the Fluence, looks at, but is the Indian regulatory framework matured enough to suggest what are the standardizations that are required to set up or to deploy any battery storage solutions in the country? Do we have necessary IC regulations? Do we have the labs or the IS regulations also? Because if not now, sooner or later we would require those, and these can also become a major challenge. We are seeing something similar for solar modules and wind turbines. And what have your experience been?
Right. So all of these are works in progress. We tend to do things when they are upon us, and I think battery storage is upon us. I think the need is upon us. The value is, people know that there's value in this. So I wouldn't say it's all there and it's perfect, and maybe it should not be, because when you create the perfect environment, then you look for the perfect fit, right? And maybe it's imperfect, maybe that's good, and maybe we'll move faster because of it. So I don't think that's an impediment. I think the impediment is the willingness of people who clearly have a value from battery storage to actively start evaluating that value and starting to size up projects and put applications for regulatory approval. I think that's what is needed. You will see that the rest of the ecosystem will fall in line and will support it.
Okay, that's helpful. One quick question on the costs. How do you see, you also mentioned earlier that the costs have not been updated, at least what we are seeing is a couple of years old costs. But going forward, what are the ranges, if not the exact number of the costs that you think where the battery storage is?
Right. So there are analysts whose job is to see where the costs are going in the future, and our knowledge is largely riding on what those analysts in the future. It's largely riding on what the analysts say. So if you look at how like I said earlier, right, it's a deflating asset. I think we were talking about a discussion earlier. It's a deflating asset, as in its price is going to be lower next year than it is this year, unlike a pumped hydro solution, which is also an energy storage solution, which for sure will be more expensive at the inflation rate at least 1 year down the road, right? So it's a deflating asset. Now, the price of batteries and battery is a key component of energy storage solution. I would say it's about 50-50 batteries and 50% for the rest of it, generally speaking. We have seen the price of batteries go as much as 17 to 18% annually, year on year, maybe 5 years back. It came down to about 15-16% a couple of years back. I think it's been maybe about 7 to 8% this year, and it's projected to be 7 to 8%, over the next 2 or 3 years. So I would say the precipitous declines in batteries have happened, and I think declines. There are projected declines in the future as well, but not as much as we've seen in the past. So I think from a price point of view, look, I'll say this: the Chile project, which we did in 2007, commissioned in 2009. Battery prices were 10 times of the battery prices today, and the project was financially viable in 2007 at a price that was 10 times the price of batteries today. There are projects with battery storage that are financially viable today that we can do today, and like I said, and those are capacity projects. There will be projects, energy projects, that will be viable with battery storage 5 years down the road, and we'll worry about them then. But there are projects right now that we can do with battery storage that are financially viable.
Makes sense. In addition to the cost itself, there's another one characteristic which is also very interesting for many, is the number of cycles that a battery can last. Typically for projects, what are the number of cycles that you account for the project that you have set up in various countries?
So see, I think the cycle concept is very highly misunderstood. The cycle concept is, for someone selling a battery, the cycle concept makes sense, because they'll sell you the battery and then they're out of there, right? You have the battery is yours now, and you'll do what you want to do with it, right? And I think in that case, and what I mean is the battery seller does not have an interest in how you're going to use that battery. They just sold you a battery. You can use it in the torchlight, you can use it in the transistor, you can use it how you want, right? But you have the battery, right? I think when we're talking about grid-connected battery storage, there are so many different ways that you're going to use that battery, right? There's so many different applications for that battery. And the cycles that you get out of the battery will depend largely on how you use that battery, right? So there are users, in which the battery would have fewer number of cycles, and there are users where the battery would have unimaginably large number of cycles. Again, it depends on how you use the battery. I mean, even if you take the simple example of your own cell phone, right? If you use it non-stop every day for 4 hours, you're on a call back to back for the next 4 hours, and you drain the battery, you will see that your battery is going to degrade faster than if you take a call, a 30-second call every 15 minutes, right? And you degrade and you use the battery over a 12-hour period of time, right? The number of cycles you get out of that battery will be very different. Same thing applies to grid-connected megawatt-scale battery storage as well.
Okay. For those who have joined us for the webinar, if you have any questions, please share them on the chat. We have some questions and we'll take them now. One of the questions that we see, as in multiple people have been asking question, is around battery recycling and circular economy. When you choose the technology, do you think about those, what will happen to these batteries later, or what is the second life use of batteries that you are?
Absolutely. So second life, so we've looked at, so see, I mean, in an EV application, the fact that it's sitting inside the hood of a car, the expectations of the battery are a little bit higher, right? So we have looked at the possibility of using second life batteries there, and that's something that we are evaluating, right? We become users of second life batteries. Now, when we use a battery, right, one thing that we do is we tell the customer that they will not be left with a used battery which is as good as hazardous waste, right? And again, that's where the environmental considerations come in, right? So we have made sure that we are holding ourselves responsible for taking that hazardous waste, what is now hazardous waste, off the hands of the consumer, right? What we don't know is whether 15 years down the road, if that hazardous waste is going to be in the money, as in the metals in that hazardous waste have value, or whether you have to pay out of pocket for the shipment of those batteries. That's something that we are not able to tell because that's so far out. But it's possible that you may have to pay to ship those batteries. It's also possible with the recycling of the metal industry kicking in, there could be value in those batteries.
But in the contract, it is your responsibility to take that battery
take those batteries off the hands of the consumer. That's right.
Okay. Okay. One of the questions that we have received also from one of the participants is, Fluence has been deploying large-scale batteries, but how do you think the market for behind-the-meter storage will evolve going forward? Of course, I'm not sure if you have plans to enter those markets also,
right.
Let's say 5 kilowatt, 10 kilowatt, or maybe 100 kilowatt systems also. But where do you think that going forward? And I'm sure both markets can still be beneficial for the Indian grid.
Right. Yeah. So we are not working. We want to work in a megawatt plus applications of battery storage. We think there are great companies that are working in the less than a megawatt space, and those are mostly battery companies. Panasonic like being one, right? So, but when it comes to a bigger deployment of battery where there is more things for the battery to do, it's not just a simple plug and play application where the battery has to, let's say, give a critical response time to then provide continuous supply power to some critical equipment. That's where we see a role for Fluence.
Okay.
Yeah, and in India, especially, we are seeing applications of that. Given that there are issues with the grid, and of course it's getting better, but there's still issues, and people are using a lot of diesel again for capacity reasons. We believe we can replace that batteries can play a role there.
Okay. We had briefly touched upon the cost, but one of the questions again that we received is, what is the typical cost of a 10 megawatt 1 hour battery system at this moment if we have to deploy one in the country? Is it possible for you to share those numbers?
No, actually, it's not, right? Because I know I get that question a lot. It's like, again, people are thinking of, I can go to a shop and get a price on a battery. Why can't you give me a price on a battery, right? Again, there are so many things that you can do with it, and that's so many things that you want to do with it. And depending on how you want to use the battery, I'll have to size it in a way, right? So that's one important consideration, right? Which is why there's no simple answer here, unfortunately. I know we all have simple answers, but in this case, there isn't one. I think the question says that, if it's this year, and that's fine. But even this year, is it going to be happening first half, second half? There would probably be a little bit of a difference, okay? What temperature is the battery working at? Is it working at 50 degrees C? Or is it working, in Shimla at 30 degrees C, right? That's going to have an impact on the price, right? How much reactive power do you want? If there's reactive power requirement, the price of the battery is going to be different, right? So there are multiple dimensions to sizing a battery, and each of them has an impact on the price. And that's why it's not easy for me to be able to just put out a price like that.
Sure. Another question probably also, this is probably a broader strategy for Fluence. Going forward, do you plan to venture, as in Fluence as a company plans to venture into green hydrogen or other upcoming technologies to supply these solutions for grid storage?
You'll have to speak to my Chief Technology Officer.
Okay. Okay. One of the questions that we received is, for specifying DOD of a battery, which is more acceptable from percentage or AH? These are very, very technical. I'm not even sure what does this mean. But when we are specifying DOD, is it for AH? Does it depend, or do we only say?
Actually, let's table the technical issues. Maybe we can take them up offline.
Sure. In terms of market sizing, going forward for grid-connected storage, what do you think is the right target if the country or if the regulator has to set up a target for 2030 or 2025? Have Fluence as a company come up with a potential for India itself, and what that number?
If I came up with a number, nobody will believe it.
Yeah.
But you know what? CA has come up with a number. CA has come up with a number which is by 2029, 34 gigawatts, 4 hours. That's the number. If you look at the optimal energy generation mix report, it came out in July. I can send you a copy if you'd like. There's a projection of a number. Yeah, so, so there you go, right? I mean, I think if there is no dearth, 2 years ago there was no due north, how much battery storage should be put as a target for economy-wide for India. There are enough indicators coming out of government agencies and organizations and think tanks based on which policymakers can put a goal. There's absolutely, and those are technically vetted, and being looked at by all the right people, and those numbers exist.
Okay, and these numbers probably, I mean, depends on who is projecting and what the economy or the grid is looking like going forward, would also vary a lot, which also means that going forward, we should set up domestic manufacturing in the country. At this moment, as you mentioned, there are challenges. There's no one actually manufacturing these batteries in the country. But what, in your view, would incentivize domestic manufacturing of batteries in India?
I think there are multiple things that go into a battery energy storage system, right? I don't think we will make everything equally well, right? Look, if I can import a battery cheaper from China because they're making it cheaper, and if I can assemble the system in India because I can move the rest of it over here, I can make transformers here, I can make containers here, HVAC here, and by the way, we do all these things well. We do HVAC very well, right? If I could then just assemble a finished product here, and then I can then export it, right? So why do we always think of creating barriers to cheaper imports? I can get a cheaper import and sell it to the world, right? My company right now is, we are assembling our equipment in different parts of the world. There is no reason why I would not assemble it in India if I did not have a lot of these tariff barriers. And I make use of, the benefits that India gives me, whether it's from, a technical human resource point of view, electrical engineers, whether it's steel fabrication skills point of view, cheaper labor cost, point of view. There are so many things that India brings to the table that we could use, but that doesn't mean that India will make the cheapest batteries as well, right? I could buy the cheapest battery, add what India can add, and export that equipment to the rest of the world. I don't see why not. Why we cannot do that.
Right. Again, adding on to this, and also one of the aspects that we should have probably touched on earlier is the financing requirement to set up these energy storage systems. And it also depends on who is setting up these storage systems. Do you think financing will be a major challenge, or at least are you experiencing the capex cost to be a major hindrance to set up energy storage systems in India?
Yeah, financing is going to be a major challenge. There is no doubt about that, right? And financing companies are going to look for, number one, they're going to look for track record of who is, providing the system, who is guaranteeing the system. That's two of the main things they look for, right? And then because see, if somebody is going to give a loan to a battery storage project, they want to make sure that it's going to produce what it's promising to produce, right? And for that, you have to have faith in the technology and the technology company and their track record and having done something like that before they will, finance the project, right? I think it's very important. I think that's a very important criteria, right? Again, it's not as simple as what's the price of battery, what's the price of container, what's the price of HVAC, oh, here's my total price of battery, right? And let me get it financed. No one's going to finance that. You will have to show that these systems have been working in a grid-connected, megawatt scale environment and working for a duration of time to get these projects financed, right? I think that's one thing. And the second thing is precedence, right? Whoever is, showing a solution will have to show precedence. You will have to have projects under very similar circumstances for the financier to get confidence in that technology, right? So I think those are real challenges, and yeah, you're right. We should not take that lightly. I think financing is going to be a challenge.
Okay, and in terms of who the financing institution is, in your conversations, has iRadar, PFC, or the major banks like SBI, are they warming up to the idea of energy storage, at least in terms of conversations that they're having? You're having with these companies, or are you part of these conversations?
Yeah, no, I will not be able to disclose, what we are doing in those conversations, but I think there's more work to be done.
Okay.
A lot more work to be done, yeah.
Okay.
We have financed these projects outside of India. Like I said, we are in 21 countries. We've done it through private banks. We've done it through international development agencies. We've done it through export banks, credit organizations, right? We've done through multiple ways, through multilaterals, whether it's the World Bank, right? We've done that, and we think we can bring that track record to a project in India and give the confidence that a financing entity needs. But I think in India, I think more work needs to be done. At least on the awareness side of things. That's right. Not to say that we can't bring a foreign financing company. We always can. Again, more precedents are going to be needed. Okay. In addition to the hardware itself, and we saw the pictures of the hardware, what about the software? How complex is the BMS for these batteries that are being set up in various countries? Right. So BMS is something that comes with the battery. Okay. Right. So the battery management, it gives you the critical parameters of the battery, right? What is important is the software that sits on top of that, right? There's a software. So BMS does not know anything about the grid, does not read the frequency, does not read what's happening from a voltage point of view on the grid. It does not look at how much solar is coming online, how much wind is coming online. It does not do any of that, right? What you need is an overarching controller that controls all the different aspects of the battery, right? Whether it is whether the air conditioning is running at the right temperature, whether the vents on the containers are in the open or closed position, what's the throughput on the transformer, right? So it's something that looks at all of these pieces of the puzzle within which the battery storage system is sitting, right? And then talk to the battery itself for it to do things, whether it wants to discharge, at what capacity, for what duration, or whether it can be charged because of XYZ happening on the grid, right? So there's an overarching system that sits on top of that, right? So we have been doing this for 13 years, battery storage, and our software, which is the overarching software, has been a work in progress for the last 13 years. So what we have is lessons learned across the 120 discrete deployments that we have in 21 countries across 1.6 gigawatts. All of that knowledge is being captured across this fleet of projects by the second that is making it into a central server, right? And that server is then analyzing different aspects of these batteries, looking at, what is the correlation between temperature and battery performance, correlation between humidity and battery performance, right? What happens if the temperature goes above a certain range, right? They're analyzing all that to then make it a battery that lasts longer, right? I'm just giving that as an example, right? So our software has developed over the last 12 years, that it has what we have learned from our discrete global deployments that is all embedded inside that software, right? And I think that's the most essential part of a battery storage system. Like I said, there's a chemistry solution, there's an HVAC solution, there's a packaging solution. How do you bring all of it together as a power solution, right? That's the part that the software does. And I think that's the most important, aspect to make the whole thing come together as a power solution. Okay. One of the things that you mentioned was that what is the requirement in the BMS automatically communicates with the battery. But in your experience with the existing project in New Delhi, is the grid smart enough to also talk to the BMS in terms of infrastructure? Does the communication happen with the existing DISCOM? It's not, right? So it's not. You need the software to be able to do that, right? So, and that's the overarching software, the energy management system. It goes by different acronyms. Right. Whoever you spoke to has a different acronym for it. I think I gave you 3 acronyms in the last 5 minutes, right? Think of it as an energy management system that sits above the battery. And that is what is talking to the grid. That's what's reading frequency, voltage, and then that is then sending signals to charge, discharge the battery. It's looking at, so basically, yeah, that's the software. But the EMS itself does not have the ability to communicate.
Right. So that overarching system that you said is actually controlling the battery and to interact with the grid. It actually, like the response time it has, like how effectively it can detect the changes and can communicate, will eventually also determine how much revenue you are getting from that installed capacity, right? Because then you can also, as you said, you can discharge it at different times. You can step up, step down, all this.
Yeah.
So all those revenue streams would eventually depend how quick is it responding to the requirements of the grid.
That's right, right. So and I think very important. I think you touched on a very important issue, right? So see, in India the rules are changing, right? I mean, we were at DSM rules. We were at version 3. I don't know exactly what's the exact denomination is, but let's call it version 3. We are now at version 5, right? In between there was version 4. I think version 4 lasted barely 6 months, right? So the rules based on which how the battery can add value to the grid changed, right? Now, if you are simply buying a battery that you're hooking up to the grid, you will be stuck with a stranded asset, right? You will have a battery, but it'll be of no use for you because it cannot do the things that because the rules have changed, right? And that's where the software layer comes in. The software layer, for example, Fluence's software layer has the ability to be changed depending on how the rules change. So you can make money out of your battery regardless of what the regulations are. I think it's such a versatile resource, unlike a coal power plant, unlike a pumped hydro system, which can do one thing and one thing only. Battery storage is such a versatile resource that there's so many things it can do. As rules change, if you have the software layer, you can tweak it to make sure that you're making money out of it. Okay. And I think your question on response time, right? I think that's more, so we have not run into a response time constraint with our technology. It's an important question when it comes to critical power needs behind the meter in CNI installations.
Okay.
Yeah, and we have solutions for, for a much shorter, like millisecond, in tens of milliseconds, kind of response time as well.
Okay, I think we are running over time. Before we close, just a final question. Going forward, I mean, from your learnings from various countries, what do you think will be the biggest disruption that energy storage systems will have on traditional grids? Either in terms of business models or discoms or generation or how we generate or distribute electricity.
Yeah, no, I think, I think we are looking at the beginning of the end of coal. I know it sounds dramatic, but what we've seen that the CEEW-CEF 1200 megawatt tender, where together with battery storage, solar and wind are supplying 6 hours of peaking power. And it was unimaginable, right? It was unimaginable till this happened. I've been talking about what batteries can do for the last 2 years. No one believed me, and all of a sudden we have this successful tender, and everybody believes me. So I think that's the biggest change. Simply speaking, that batteries will do, and I think it will do that in the capacity market. I think so. So the 6 hour peaking power from the battery is in fact a capacity play. Right? There are many more things that batteries will do in the capacity space, right? In fact, even the standard, coal assets that we are dealing with, that are highly underutilized, I think even to enable them to die a respectful death, I think batteries will play a role, And I think the fact that, India does not have gas, and our only flexing option is coal, and I think that's the main reason. That's where batteries will play a role to help coal do flexing gracefully, and then walk away into the sunset.
Okay, that's very helpful. Thank you, Rupam, for joining. If you have any final comments, we'll take it. Otherwise, any regulatory recommendations that you may have for MNRE, CEEW or other?
No, I think I've already made my 2 recommendations. Like I said, economy-wide goals, and please don't put tariffs on us. We're trying to do something that's super important for the country and the economy.
Okay. Thank you all on the call for joining us. Thank you, Rupam. Thank you, Akansha, for the webinar today. The webinar will be put up on YouTube and you'll receive a link in a week or so. But if you have further questions, you can reach out to us at cef@ceew.in. We'll try to address these questions or we'll pass on to Rupam to answer these questions. Going forward, we'll have more upcoming webinars on the module technologies, advances in operations and maintenance of power plants, transmission and infrastructure, financing, inverter technologies, and others. Thank you again for joining. It was pleasant having you. Thank you.
Thank you, Rishabh.